All right, geometry, here we go with lesson 815, finding the areas of regular polygons. Okay, now remember what a regular polygon is. That means that all the sides are equal, okay, in a polygon. So if you think about like a square, all four sides are equal. In a hexagon, regular hexagon, all six sides are equal. Okay, that's what we're looking at today, and finding the area. So if you think back to what area means, you guys should know what that means. Okay, it's obviously when you're finding the amount of space that a shape takes up. Okay, so let's just review. I want you guys to take 2 minutes here. Find the area of this triangle. You guys should know how to do this. Okay, find the area of that triangle. Write down your method. Write down the area. You got 2 minutes. Pause the video. Go. All right, so you should have paused the video here. Hopefully you guys remembered how to do this. The area of a triangle, remember, it is area equals 1/2 base times height. Okay, that's the formula for the area of a triangle. So it gives you the base here, it gives you the height, 6 and 5. So we just plug in those numbers for B and H. Okay, plug that in. 1/2 of 6 is 3. 3 times 5 is 15. So the answer is 15, and our units there are feet. So make sure we put square feet when we're doing area, okay? Because it's the amount of space that it takes up. So you want to measure it in 2 dimensions, 2-dimensional space. So that's why we put square feet. Okay, so it's 15. There is our answer. Okay, the reason I'm having you guys review how to find the area of a triangle, this is going to be key in today's lesson today. All right, so if you take a look at number 47, we've got 2 shapes here. Okay, and in the book, it asks you to find the area of each of these shapes 2 times. Now, it wants you guys to really explore this one. So I want you guys to try this out. Pause the video for at least 10 minutes. And I want you guys to wrestle with this. So I want you to find the area of this square when it gives you this distance right here is 6. Okay, so all you know is that distance is 6, and you need to find that area. And it wants you to do it 2 times. If you guys can do it 1 time, that's awesome. That's fine. And so at least find it once, and then it wants you to find the area of this regular hexagon. So you guys got to try to figure out how to split this hexagon up into triangles that you can find the area of, okay, and find the area of that regular hexagon. Okay, and show your work down below here, and yeah, so try that out. So at least 10 minutes. You can go longer if you need to. Yeah, go ahead. All right, so hopefully you took some time, tried these out, wrestled with them a little bit. Let's go over a couple ways of how to do it. Okay, this first one with the square. Something we learned back in chapter 7 is that these diagonals are perpendicular bisectors since it is a square. Okay, and that's a property of rhombus, which a square is like a type of rhombus. So there's 4 right triangles in here, and not only are they just right triangles, they're isosceles. Okay, because these sides are going to be equal. So for our first method here, one method that you could put down is you could find the area of one of these isosceles right triangles and multiply it by 4, because there's 4 of them in there. Okay, so let's do that. That's going to be our first method. So we've got, I'm just drawing this one right here, and I'm rotating it on its side there. So since they're perpendicular bisectors, all these 4 segments here are going to be equal to each other. Okay, so they're all 6. Okay, so we've got that much. Now you have a triangle here with a base and a height. So we can find the area by using our area equals 1/2 base times height formula. So let's go ahead and do that. So area is 1/2 base times height. So 1/2 of 6 times 6. Half of 6 is 3, and 3 times 6 is 18. Let me zoom in just a little bit here. Okay, so we get 18, and now that's just for one of the triangles here, and we've got 4 of them. So take that times 4. And they didn't give us units here, so I'm going to put square units for this. And then you want to take that times 4, because there's 4 triangles. And if you do that, you get 72 square units. All right, there you go. So that's one method. The other method is a little bit trickier, okay, but we'll go over it anyways. If you look at these triangles, since they're isosceles right triangles, that's another name for one of our special right triangles, the 45, 45, 90. So if we look at the 45, 45, 90, let's just draw a picture of this again. So, or I'll just use this one. Okay, these angles have to be 45 degrees here and here. And now if you look at the property of the 45, 45, 90, it goes x, x, and then x square root 2. So this side length right here has to be 6 square root 2. Okay, and now since you know this is 6 square root 2, it's a square, so all of these sides have to be equal. Okay, so you can say this down here is also 6 square root 2, and now you can find the area by just multiplying these two together. And we should get the same number, so let's try it. So just the area of a rectangle, or a square in this case, you're taking base times height. So we're going to take 6 square root 2 times 6 square root 2. 6 times 6 is 36. And then square root 2 times square root 2 is square root 4. Sorry, hopefully you guys can still see that. Okay, so 36 square root 4. And the square root of 4 is 2. So 36 times 2, you end up getting the same answer, 72 square units. All right, so there's 2 different methods to find the area of this square when you're given this line right here, which is called a radius, going from the center to a vertex of a square. That's called the radius. Okay, all right. Next, we've got the tough one here, finding the area of a regular hexagon. So this one, you guys want to start off by dividing this into congruent triangles. So you want to draw all of the diagonals of this hexagon. So let me do that real quick. Try to do a better job what I'm doing there. Okay, there you go. So now that you've drawn your diagonals, there's 6 triangles here that are all congruent with each other. Okay, and now what I want you to do is I want you to think back to yesterday when you were using these formulas. Okay, because the one formula that we're going to look at today is the interior angle of a regular polygon, because that's what we're dealing with today, is regular polygons. So if I want to find just one of these angles right here, I can use that formula. Okay, this formula right here. So 180 times n minus 2 divided by n. So this is a hexagon here, so we're going to plug in 6 into this to find one of these angles. Okay, so if I do that, let's take 180. Let me get that on the screen here. So you're going to take 180 times 6 minus 2 divided by, not 2, divided by 6. This is your number of sides. Okay, and if you do that, that should end up giving you 120 degrees if you plug it in correctly. 4 times 180 divided by 6 is 120. So that means this full angle right here and all of these are going to be 120 degrees. Okay, now why does that help us? Well, we need to find the area of one of these triangles. That's going to be our first method here. Okay, forgot to say that. So we have a triangle with a base of 8, but we don't know the height. So we need to work on finding this height of this triangle. Okay, so the height needs to be perpendicular, and we can find this angle down here because what this is doing when we created these diagonals, that's bisecting each of these angles. Remember, that means cutting in half. So if this whole angle is 120, this angle down here is going to be what? That's going to be 60. Okay, so that's going to be a 60-degree angle right there if you cut that angle in half. Okay, so hopefully you guys are kind of following that we're taking this triangle right here. Okay, and now we're going to try to find the area of that. We got to find the height first. Okay, so we've split this triangle in half. I'm going to draw that off to the side here. We split that in half, and now we've got this triangle right here. And we know that angle on the bottom is 60. So this is actually a 30, 60, 90 right triangle, which is super helpful for a hexagon, okay? So with this side right here, this is 8. If you split that in half, this is going to be 4, okay? And now, since it's a 30, 60, 90, if you use the shortcut, we can say this is going to be 4 square root 3. Okay, super handy to use that shortcut. So now if I want to find the area of this triangle here, let's go back to this one. So if I want to find that area, I now know the height is 4 square root 3. So I'm going to take 1/2 base of 8 times the height, 4 square root 3. And let's see, half of 8 is 4. 4 times 4 is 16. So we've got 16 square root 3. And I would keep the square root 3 as long as you can until the very end, and then we'll get the decimal. Okay, so we've got 16 square root 3. That's the area of one of these equilateral triangles. So if we look there, how many equilateral triangles do we have? Well, we have 6, because it's a hexagon. Okay, we have 6 of those triangles. So I want to take this, and I want to take that times 6, because there's 6 triangles. Kind of like what we did here, we took our area of one triangle times 4. Now we're taking it times 6. And 6 times 16, that's going to be 96. So we get 96 square root 3. And that's your area. Okay, so it's square units there. There's your area. You could leave your answer like this if you wanted to, or you can get the decimal answer, which if you do that, 96 times the square root 3, you just type that in your calculator, get the decimal, and it's around 166.3 square units. Okay, there you go. All right, that was one method of finding the area. Now again, this one was really tough. If any of you got the answer to this before I showed you guys, you should get a piece of candy. Okay, so ask the sub for a piece of candy. If I'm throwing you under the bus, sorry. Okay, all right, so that was one method. If you wanted to know another method, you could actually split this into 2 trapezoids. If you drew this line right here, we've got a trapezoid up here and a trapezoid down there. You still need to find the height. So you'd still have to find that this is 4 square root 3 using that special right triangle. Okay, but you could use the trapezoid formula and multiply it by 2. Okay, so that was your other method. Okay, so your answer's down here. This was 72 and 166.3. Okay, I don't mind if you guys don't put your methods there, as long as you understand what you did up here. You don't have to write anything for the method. Okay, flip it over to the back. All right, here we go. We've got 2 more that we want to practice here. Okay, and we're going to see how we do. So I'll get you guys started on this first one, on letter A. So first thing you got to do, it tells you that it's a regular polygon. So you want to count your sides and figure out what type of regular polygon it is. So count the sides. Okay, and you should count that there are 9 sides here. Okay, and now what we learned from that front page is that you want to divide these up into equal triangles. So what we're going to do here is you're going to draw lines going to each vertex here. Okay, and now you end up with 9 congruent triangles, and they have to be congruent because if you guys remember from that mirror lesson that we did, these are all reflections of each other. To make that regular polygon, they all have to be congruent. So each of these triangles are congruent. Okay, so now what you're going to do is we are going to take this triangle and we're going to split it up. Okay, so let's draw that triangle. This time we know the radius is 11. Okay, we don't know the side, we know that the radius is 11. And then what you're going to do is we're going to split this up, and we need to find our base here. We need to find the base and we need to find the height. Okay, so let's split this triangle. Let's split it up. So I'm going to draw an arrow going off to the side here. And let's split it up into a triangle like this. Okay, I know this is 11, and I'm going to call this B, and I'm going to call this A. Okay, just using those as our variables. Okay, so here's the deal. We want to find this angle. So remember what we did on that hexagon problem. We found the full angle first. We want to find that full angle and then split it in half because these are bisecting those angles. So use that formula. 180 times n minus 2 divided by n. Except this time we've got 9 sides. So let's go ahead and show our work up here. So 180 times 9 minus 2 divided by 9. That gives you 140 degrees for each of those interior angles going around there. Okay, 140 degrees. Okay, so now if we were to split that in half, remember this is bisecting that, so half of 140 is 70. So you're going to put 70 in this little spot right here. All right, now I want you guys to see if you can figure out A and B from this triangle here. You're going to have to use some trig. Okay, so use some trig, show your work, find A and B. So pause the video and go. All right, so hopefully you pause the video here. To find A and B, to find A, you have to do sine of 70, and that equals A over 11. That's an A. Okay, and then if you, since A is on the top, you multiply here. If you remember how to do the trig stuff, take 11 times sine of 70, and that's around 10.337. I would go to around 3 decimals here because we're going to be using that number, so try not to round as much as you can, so that way your answer is more accurate. Okay, and then to find B, since this is the adjacent side and this is the hypotenuse, we got to use cosine. So cosine of 70 is B over 11. Type that into your calculator. You should get 3.762. Again, go to at least 3 decimals. The more decimals you round to, the more accurate your answer is going to be. Or if you know how to save a number on your calculator, you could save these in your calculator. All right, so now let's go back to what we've just done here. Now B, so this was A, this was B. I'm going to underline them because those are pretty important. So we found A and B. Now B was half of our base here, so we got to take, if I want to know this full length here, that's going to be 2B. So you want to multiply this number by 2. Okay, so I'm trying to think of the best way to say this. Yeah, so we can just do it that way. So if you take 2 times this number here, it's going to be approximately 7.524. Okay, so we have that number. And then our height, A, is going to be approximately 10.337. So if I want to find the area of this triangle right here, I want to take 1/2 base times height. Okay, so area of the triangle, and let's kind of label our work here. So this is for the triangle. Area is going to be 1/2 of 7.524 times 10.337. Okay, and then if you plug that into your calculator, you should get around 38.8. Now, if you rounded these numbers differently, you might get a slightly different number. Hopefully, you know, go to a few decimals here. So don't round this yet, because now what we have to do is we have to take this times 9 triangles. So multiply this by 9 triangles. Okay, and then our total area of the entire polygon here, you should get around 349.998, or we're just going to round that up to 350 square units. Okay, 350.0 square units. All right, okay. I know that probably seemed like a lot, okay, but it'll get easier, okay? So after doing that one, I'm gonna give you guys the formula for finding the area of a polygon. So essentially what we've done here is we've taken 1/2 of our b value. Sorry, we took 1/2 of this, which would just be equal to b. Okay, it kind of cancels each other out there, if you know what I'm talking about. And then this number right here is just a. And then you have to take that times your number of sides. So if we want to develop the formula for this, essentially what we did here was area was 1/2 of our side length times our apothem is what we call this. Okay, I'll go over that again, what the apothem is, and then times our number of sides. Okay, so our formula is 1/2 SAN is what we call this. Okay, I want you guys to write this at the top because you'll use this in the future. Okay, so area is 1/2 SAN. So S is for side length, A is for apothem. Again, I'll go over that again on what that means. And then N is your number of sides. So those are the three things you need to know in order to find the area of a regular polygon, okay? So I want you guys to, so with this right here, so this one, we are given what is called the apothem. So when you go from the center of your shape perpendicular to a side, that is the apothem. Okay, so I'm just going to label that right now. We got the apothem. Okay, so all you guys need to do on this one is you need to find your side length, because you know your number of sides. You can just count that. You know your apothem is 5. You need to find the side length, and for that you need to split it up into triangles and find the b value in that case. Okay, so go ahead and pause the video here, try and find that side length there, and then we'll go over it. All right, so let's go through it. If you split this up into triangles, first of all, we have I believe it was 10 sides here. Yeah, 10 sides. Let's write that down. So we got 10 sides. So let's split our triangle up here. If you type in your formula to find the interior angle, plug in 10 into this formula, each of these angles going around here should be 144. But if you split that in half, because our radius here splits that in half, this is going to be 72 degrees. Okay, so we got 72 degrees there. We know our apothem is 5. Okay, and we're trying to find our side length. So let's split this triangle in half. Let's draw that off to the side here. So draw your half of this triangle. So we know this is 5, and we know this is 72. Now we can use trig to find that bottom side. I like to call it B. Okay, so now you can use some trig. In this case, you're going to use tangent. So I'm going to write tangent of 72 equals 5 over B. Okay, cross multiply here and divide. So 5 divided by tangent of 72, that should give you around 1.625. Okay, so 1.625, and now that is only half of your side length. So if I want the total side length, if this is S, okay, from our 1/2 SAN, that's our side length that we want, you want to take this number times 2. okay? So S is going to be 2 times this. So let's put that 2 times 1.625. And that's going to be approximately 3.25. Okay? So now we have our side length, we have our apothem, and we have our number of sides. Now you can just plug that into your formula right here. Okay? So let's plug it in. Area is going to equal 1/2 of our side length, which is around 3.25, times our apothem, which was 5, and then times our number of triangles, or number of sides, I should say, which is 10. Okay, and if you type all this in correctly, you should get around 81.2 square units there. Okay, there you go. All right, guys. Okay, that's kind of the main portion of this lesson that I wanted you guys to get through. If you guys still have some time left over, which you probably will, I want you guys to try out number 51. Okay, this one, read through the problem in the book. It's about this lady here. She's making a pentagonal garden, and she's trying to figure out how much fertilizer to buy. Okay, so go ahead and find the area of her flower bed if you know this side. So figure out the apothem here. You got to find that. Plug that into our new formula, okay, for the area of a regular polygon. And guys, if you're still struggling with this, just practice it. Okay, it's going to take some time. Just get used to the steps. Okay, and you'll get it. You'll get down eventually. It's just going to take some practice. Okay, so try out this problem. Show your work off to the side here. Draw that triangle, and I'll share the answer with you in a little bit here. Okay, so pause the video here, and then I'll share the answer, and then we'll end the day. All right, guys. So you should have found your apothem, which, by the way, your apothem, so that line segment right there, you should have gotten around 10.323. Okay, and so then your side length was 15, your number of sides is 5. So if you plug that into your formula here, you've got your side length was 15, your apothem was 10.323, and your number of sides was 5. If you plug that in all correctly, you should get around 387.1 square feet. So that's the area of the flower bed. And then it says in the problem that each bag of fertilizer that she buys covers 150 square feet. So if you take 387.1 divided by 150, that ends up giving you around 2.58. So she would need to buy at least 3 bags of fertilizer to cover her pentagonal flower garden. So you'd put she'd need to buy at least 3 bags of fertilizer. Okay? All right, guys. Hopefully most of that made sense. We're going to practice some more of this in the future. Help each other out. You guys are doing awesome. Okay, keep up the good work.